right, hello and welcome to Covalent Bonds. Let's talk about the word covalent first. CO. What does the word CO mean? We have co-op, we have cooperate, we have companies. Like, what does a company do? A company is a bunch of people getting together to manufacture a product or render a service that allows them to make money and make a living. So the same thing here. They're cooperating valence ring electrons. All right, so covalent, a valence ring, and that's a kind of bond. Let's use fluorine, for example. We used chlorine in the last one. So fluorine, first things first, if you look at your periodic table, which should be on the next page, we see that fluorine is 8. So it's 7. It's a halogen. It means it's got 7 electrons in its outermost shell, which is called the valence shell. Let's turn black for our valence electrons. So there's 2 here, 2 here. We're going to do the Lewis dot, but we'll kind of put them on to make it easier for us to see. We'll put one down here. Let's draw another fluorine because we're going to have 2 fluorines bonding together covalently. All right, so once again, we do the electron configuration. And if you check again, you'll see that there's 2, 4, 6, and 7 valence electrons on that fluorine as well. Let's group these so that I can slide it around. Group. Try that again. Okay, so this fluorine is grouped together. All right, so this fluorine is going to want to share this 7th valence ring electron so that 2, 4, 6, 8, 2, 4, 6, 8. Each fluorine now has 8 electrons when they share. That's called covalent bonding. All right. This also, if you'll notice, we're sharing one pair. So out of this, we want to say that this is a single bond. Right, single bond. All right, so a single bond shares one pair of electrons. Let's pick a different color and another element. Let's run down here and let's do oxygen. We'll do 2 oxygens. Well, if you go to the periodic table, we have oxygen. You see 8, 7, 6. All right, so everybody in this group has 6 electrons in its outermost shell. So let's put that configuration in here. We have 1, 2, 3, 4, 5, 6. Sorry, I'm counting all on the same one. Let's put these over here like this. Let me change my mind on you, if you will. All right, and I'm going to take this pair. So we need one more pair over here. Ooh, that's a messy one. And we may have to do the eraser here and fix this real fast. Oh, I've messed it all up. Okay, let's go back to blue. And let's put that oxygen back. We're going to want 6 valence electrons, and we're going to have 2 here. I'm putting 2 here on purpose. So we'll put 2 over here, and we'll put 2 over here, and it kind of helps. All right, so we have 2, 4, 6. And I just messed up again. All right, well, this isn't working out so well today. Let's try this one more time. Hopefully you're enjoying me drawing oxygens. And we'll get the black, and we'll do 1, 2, 3, 4, and then we'll put 2 here. All right, let's quickly, before we mess up again, group this one so we can slide it over. All right, this oxygen, what does oxygen want? It's got 2, 4, 6. Of course it wants 2 more electrons. But since it only has 6, you'll notice that this oxygen slides over and is going to share 2 pairs of electrons. So there's a pair there and a pair there. By sharing this pair of electrons, we now have 2, 4, 6, 8. And then here we have 2, 4, 6, 8. So now this oxygen is stable because it's got 8 electrons in its outermost shell through sharing, covalently bonding. And this is called a double bond. So we'll write double bond. Let's do one more. There's actually something called a triple bond. There are no quadruple bonds, so you don't have to worry about those. So we'll do triple bond. We'll draw an arrow over here. All right, so what's going to be an example of our triple bond? let's scoot it down so we can see it here. Let's use nitrogen. We'll have a nitrogen here and a nitrogen here. If you go look at the periodic table on the next page, we have nitrogen 8, 7, 6, 5. So there are 5 electrons in the outermost shell. So let's go, and I'm going to do it kind of weird here. I'm going to do 1, 2, 3, and then we'll put 2 back here, 4, 5. All right, same with this one. 1, 2, 3, 4, 5. And the reason I did that is so we can see that nitrogen, excuse me, nitrogen has 1, 2, 3, 4, 5. But if it shares 3 pairs, these 2 bond, these 2 bond, and these 2 bond, if these 3 pairs bond, then we'll have 1, 2, 3, 4, 5, 6, 7, 8. So each nitrogen will have the equivalent of 8, or a stable outer shell. Let's see if I can group these. Actually, I think we're just going to scoot them together and we'll be good at that. All right, and that's called a triple bond. Keep in mind that covalent bonds are not as strong. Let's write that down here somewhere. They're not as strong as ionic bonds. And that makes sense, and that's actually kind of a good thing. Obviously, if a metal were to show up, these fluorines are sharing one bond each, so each of them has an electron, and if a metal were to show up, like one of the alkali metals, this fluorine would quickly bond like sodium, and we'd have what we'd call sodium fluoride. Right? So these are not as strong, as I mentioned earlier, as ionic bonds. I believe that's a test question. Let's go to the next page and figure out who's going to create covalent bonds. Well, nonmetals bonding with nonmetals are going to create covalent bonds. Earlier, remember, I had ionic bonds were metals and nonmetals. Well, now we have nonmetals bonding with nonmetals to create ionic bonds. Also, I might mention it often, most of the time, your metalloids bonding with nonmetals will be in a covalent bond as well. And for those of you who are curious, anytime we have a metal bonding with a metal, obviously a metallic bond seemed like a good idea. I hope this has helped. Thank you, and I will see you tomorrow.